Hello, this is Mr. Brooks, and welcome to Lesson 10.7, Areas of Circles and Sectors. In this lesson, we're going to find the areas of circles, sectors, and segments of circles. Area of a circle, pi r squared. We're already supposed to know that. Take the radius, square it, multiply it by pi. Okay, example 1 asks us, how much pizza would be in a 12-inch pizza? How much more pizza would be in a 12-inch pizza than in a 10-inch pizza? So you're going to find the area of the 12-inch pizza and then subtract from that the area of the 10-inch pizza. So please pause the video while you try to figure this out. Okay, in the 12-inch pizza, you're going to have pi r squared, which would be pi times 6 squared, which would be 36 pi square inches of pizza. In the 10-inch pizza, you're going to have pi r squared, which is the radius is going to be 5, so you'd have 25 pi. So when you subtract these, how much more is in a 12-inch pizza than in a 10-inch pizza? Would be 11 pi square inches. 11 pi square inches more. So you almost get another half a pizza just by increasing the radius by 1 inch. And if you plug this into a calculator, you're going to see it's 34.56 square inches more is how much you get in how much more you get in a 12-inch pizza than a 10-inch pizza. All right, quick check number 1 says how much more pizza is in a 14-inch pizza than in a 12-inch pizza. Please pause the video while you try to figure this out. In a 14-inch pizza, you're going to get pi r squared, which would be 49 pi square inches. In a 12-inch pizza, you're going to get 36 pi square inches. So you will get, you're going to subtract the 12-inch from the 14-inch, and you'll get 13 pi more square inches, which is approximately 40.84 square inches, about 41 more square inches in a 14-inch pizza than in a 12-inch pizza. Next, for part 2, we need to know what the sector of a circle is. Sector of a circle is a region bounded by an arc of a circle and 2 radii to the arc's endpoints. In other words, in the picture down below, we have sector AOB of circle O. Okay, how are we going to find the area of the sector? Well, you're just going to find the area of the circle and take whatever part of the circle you want. So please pause the video while you try to figure out example 2. In example 2, you want 72 3/60ths, or 1/5, the area of the circle. What's the area of the circle? Pi r squared, which would be 400 pi. So you want 1/5 of 400 pi. So the area of this sector is going to be 80 pi. It says leave it in terms of pi, so we are not going to punch that into our calculator. Our answer is just 80 pi. All right, now let's try quick check number 2. It says a circle has diameter 20. What's the area of the sector bounded by a 208-degree major arc? Round your answer to the nearest tenth. Please pause the video while you try to figure this out. Okay, here I have a circle of radius 10. It says the diameter is 20, so the radius is 10. We're trying to get the area of the shaded region. This part right here has an arc measure of 208. So we want 208 3/60ths of the area of the circle. Area of the circle, pi times r squared. Pi times 10 squared. So we want 208 3/60ths of 100 pi of the area of the circle. We can reduce that down if you want to 26 45ths of 100 pi, but you don't really need to. You can just plug it straight into a calculator. Reducing that doesn't really make it much easier. It's just extra work. Just punch into your calculator 208 times 100 pi divided by 360. Hopefully you got the area of the shaded region to be approximately 181.5 square units, in this case square centimeters. Okay, in the last part of this lesson, we need to learn how to find the area of a segment of a circle. Well, in the previous part, we learned how to find the area of a sector of a circle. Now we're going to learn how to find the area of a segment of the circle. Well, first you better understand what a segment is. It says it's part of a circle bounded by an arc and the segment joining its endpoints. That's the segment, and you can see a picture of what a segment is. How do you find area of the segment? You take the area of the sector minus the area of the triangle. Gives you the area of the segment. Okay, let's take a look at one and see if we can figure out how to do this. Okay, example 3 says, find the area of the segment of the circle with radius 10 and a central angle of 90 degrees. Please pause the video while you try to figure this out. Okay, as it said on the previous slide, we're going to find the area of the sector, and then we're going to subtract from that the area of the triangle, and that will equal the area of the segment. Alright, what's the area of the sector? Area of the sector is going to be 93/60 or 1/4 the area of the circle. The area of the circle is pi times radius squared, pi r squared, which would be 100 pi. So 1/4 of 100 pi. The area of the sector is going to be 25 pi. Now from that, we're going to subtract the area of the triangle. Area of the triangle is 1/2 base times height. 1/2, the base is 10, and the height is also 10. So 1/2 base times height, 1/2 of 100, which equals 50. So from that, we're going to subtract 50. So the area of this segment is going to be approximately, to the nearest tenth, 28.5 square inches. Alright, quick check number 3 says, a circle has radius 12. Find the area of the smaller segment of the circle determined by a 60-degree arc. Round your answer to the nearest tenth. Please pause the video while you try to figure this out. Okay, so we're trying to find the area of the shaded segment. We know the central angle is 60 degrees, and then we know it's got a radius of 12. How are we going to do this? First, we're going to find the area of the sector with the 60-degree angle with radius of 12. Then we're going to subtract from that the area of the triangle that again has a central angle of 60 with a radius of 12. Okay, the area of the sector is going to be 60/3/60 the area of the circle, which again is pi r squared. Pi times 12 squared. So you're going to have 1/6 of 144 pi. Now, which is 24 pi. That's the area of the sector. Now from that, we are going to subtract the area of the triangle. Now if we're trying to find the area of this triangle, where the both radii are 12, and it has a 60-degree angle, we're going to have to find the height of this thing. So this leg of this 30, 60, 90 would be 6, so the height is going to be 6 times the square root of 3. So the area of the triangle is going to be 1/2 the base, which is 12, times the height, which is 6 times the square root of 3. So it's 6 times 6, 36 times the square root of 3. So we're going to punch in 24 pi minus 36 times the square root of 3. Please pause the video while you punch that in. Again, to the nearest tenth, hopefully you got 13.04, and to the nearest tenth, that is going to be 13.0, and without that 0, you will be losing points. This concludes Lesson 10.7 and Chapter 10.